Okay, so now that we have talked about what rational numbers are, we have talked about fractions and dealing with those, turning fractions to decimals, decimals to fractions, talked about decimals. We've talked about identifying rational numbers and square roots, cube roots, things like that. We're going to take all of that we've talked about, those different types of rational numbers, we're going to combine them into one, and we're going to compare them. These numbers are going to be written different ways. We're going to be able to say which one is bigger, which one is smaller, ordering different sets from least to greatest, doing this by our knowledge of these rational numbers. Okay, so first thing, as a review, rational numbers, integers, fractions, repeating decimals, terminating decimals, they can be positive, they can be negative, but those are all the different types of rational numbers. So a few examples of rational numbers once you get this definition down. So they could be something like -7. We could have a fraction like 1/2. We could have a repeating decimal, so 2.3 repeating. We could have a terminating decimal like 0.7. Or remember, like we talked about yesterday, the square root of 25, I'm sorry, not yesterday, the week before, the square root of 25, which is 5. So those are all different ways that you're going to see a rational number written. And remember, they can be positive or they can be negative. Okay, so when comparing rational numbers, we want all of our numbers that we are comparing to be in the same form. That means we want all of our numbers to be either fractions or we want them all to be decimals. And so we might have to use what we've talked about with turning fractions into decimals and decimals into fractions and use this knowledge to compare these rational numbers together. So if we want to turn all of our numbers into fractions, we're going to make all numbers fractions, then get a common denominator. So think back to when we talked about getting a common denominator and saying which number is the bigger number. It's always easier to figure out what the bigger number is when we have a common denominator. So that's why we want to do that. Once we've got a common denominator, just compare the numerators to each other. Okay, if we want to make them all decimals, which a lot of times this one might be easier, make all of our numbers decimals, and then we're going to go by place value, tenths, then the hundredths, then the thousandths, to see which number is greater. And I'll show you an example of that here in a second. Then finally, to write a percent as a decimal, remove the percent sign and move your decimal point 2 places to the left. So 35% would be 0.35. 70% would be 0.7 or 0.70. So then 7% is not going to be 0.7. We move it 2 times to the left. It's going to be 0.07. So one thing to remember, anytime your percent is less than 10%, so 1 through 9, there should be a 0 after the decimal point. So 7% is going to be 0.07 because 0.7 is 70%. Okay, so looking at a few examples. So we see that -1 5/6, -1 1/2, and we want to write inside of here, is it greater than, less than, or equal to? So that's the first type of problem we're going to see with comparing these. If they are both fractions, I would leave them both as fractions and then just use a common denominator. First of all, if both numbers are negative, you might want to get this down. Negative means opposite. In other words, the bigger number is actually smaller. So one example of this, -4 is smaller or less than -3. So negative means opposite. You've got to think instead of the bigger number, the smaller number is actually bigger. So -4 is less than -3 because negative means opposite. So if it says greatest to least, you would, and they're all negative numbers, you would actually think least to greatest because negative means think opposite. So let's look at 1 and 5/6 and -1 and 1/2. Let's get a common denominator. So for 2 and 6, common denominator would be 6. So we're going to do 2 times 3 and 1 times 3. So -1 1/2 is really -1 and 3/6. Now normally 5 is greater than 3. 1 and 5/6 is greater than 1 and 3/6. But since it's negative, think opposite. So 1 and 3/6 is going to be greater, -1 and 3/6. So the greater than side is the one that is open. So the open side should point towards the greater number, and the greater number is -1 and 1/2. Because with negatives, we have to think opposite. For positives, we would just look at it normally. Okay, so our next one, 7/12 and 0.875. I would make both of these decimals. You've already got 0.875, so then let's make 7/12 into a decimal. So we're going to divide. 7 goes on the inside, remember. 12 goes on the outside. Doesn't go into 7, so add our 0.0. 12 goes into 70. It only goes into 75 times. And at this point, I can actually stop. Think about why I could stop my division right here. Well, notice I have 0.5 something and 0.875. Well, 0.8 is obviously greater than 0.5. And so that's why that's my answer. 0.8 is definitely going to be greater than 0.7, 0.5. Okay, and then for 1/5 and 7/50, I would get a common denominator for this one. And the easiest one to do is 50. So 5 times 10 and 1 times 10. So 1/5 is 10 over 50 or 7 over 50. Well, 10 is greater than 7. So that would be our answer. Greater than points towards this 1/5 or the 10 over 50. So using that, what we just talked about, either make them both fractions, make them both decimals, and then compare by place value. Go ahead and do those 3 on your own. Pause your video. Okay, so with our first one, they're both negative. Remember, negative means think opposite. So let's get a common denominator. For 9 and 4, it would just be 36. So we're going to do 9 times 4, 5 times 4, then 4 times 9, and 3 times 9. So this is going to be -5 and 20 over 36. And then -5 and 27 over 36. Normally, 27 is bigger than 20. Since they're negative, it's actually smaller than 20. So it'll look like this. Negative, remember, you got to flip it because it's opposite. Okay, next we've got 4/5 and 0.8 repeating. Now, if it is 0.8 repeating, it's going to be 0.888, and the 8 never stops. 4 over 5, if we change that to a decimal, that is just 0.8. What would come after that 8? If it's 0.8, well, that would be 0.80, and it's just going to be zeros after that. So compare these two. 0.80 or 0.88. So 88 or 80. 888 or 800. Well, 0.8 repeating is going to be greater, because the 8s are all greater than the zeros there. Okay, and then the last one there, 5 over 6 and 7 over 9, get a common denominator. For 6 and 9, it doesn't matter. You could use 54. 6 times 9, 9 times 6. You could also have done 18 as well. Okay, let's just do 6 times 9 and 9 times 6. You're going to get the same answer regardless of what common denominator you used, as long as you multiply correctly. So 5 over 6 is 45 over 54. 7 over 9 is 42 over 54, which means 5/6 is greater than 7/9. Okay. So the last type of problem that we might see is taking a set of numbers, a collection of numbers, and ordering it from least to greatest. So the way that we do this is we're going to make all of these numbers decimals. So step 1, or maybe a note, is make them all decimals, unless they're all fractions, but usually they won't be. And I'm going to write these over top of one another, like this. 3.44. And I'm going to add a couple numbers after that 4. If it's a terminating decimal, remember what number comes after the 4s? It would just be a couple of zeros. And then we've got pi. Pi is 3.14, and the next two numbers are 1, 5. Then we've just got 3.14. So if it's just 3.14, remember, it would just be zeros after that. So 0, 0. And then 3.4 repeating would be 3.4. So just a bunch of 4s after that, because the 4s never stop. So once I have written those down, I am then going to look at each place value. So the 3s are all the same. Okay, so I'm going to move to the next one. Then we've got the 4s, and there's 2 1s. So I want the least number to come first. Well, the least number is going to be one of these 2 1s. Okay, because 3.1 is less than 3.4. So just looking at these two, okay, just looking at those two, which one is going to be smaller? So continue to look. 3.141, 3.140. Well, 3.140 is smaller, so that one is the first choice. 3.141 would be second. So then I'm going to turn my attention to the 3.4 and the 3.4 repeating. 3.44, 3.44, 3.440, 3.444. 0 is less than 4, so that is third. And then the greatest one is 3.4 repeating. So the last thing I'll do is rewrite these in order from least to greatest, but write them as they are in this set. So the smallest number we said was 3.14. Next smallest was 3.1415. Remember, that was pi. So write pi next. And then I have 3.440, which was just 3.44. And then we said the greatest number was 3.4 repeating. So that is our set from least to greatest. So let's do one more together as well. So 23%. 23% would be 0.23, and I'll add a couple of zeros there. 0.21, so 0.2100. 1/4 is 0.2500, and then 1/5, if you did 1 divided by 5, would be 0.2 or 0.20. So now looking at these, okay, I've got all 0.2s, okay, if I'm looking at this place value. So go one step further. So this is where they all get different. Well, what's the smallest number in this line? Well, 0 is, so that's going to be the smallest. What's the next smallest? Well, then 1, and then 3, and then 5. So putting these back in order, the smallest was 0.20. Remember, 0.20 was 1/5. And then we've got 0.21, which was just 0.21. And then 0.23, which was 23%. And then 1/4, which was 0.25. So this is my set in order from least to greatest. So you want to make all those decimals, compare each place value one by one. That's going to tell you which one's least, which one's greatest. Remember, if they are all negative numbers, you think opposite, you go really from greatest to least. Opposite means negative. Okay, so then our last problem that we will look at is this question. So Kelvin is the quarterback of the football team. In his first game, he completed 67% of his passes. The next 3 games, he completed 0.65, 3/5, and 64%. What was his highest completing passes number? What was his lowest? So if I write these out, I've got 67%, which is 0.67. I've got 0.65. I have 3/5. 3/5 is 0.60. And I've got 64%, which is 0.64. So the highest completing passive percentage was 67%. And then the lowest was that 60, which is 3/5. So those are my 2 answers there. So like I said, just a word problem, but we're still comparing those rational numbers. Right, so once you've got that, you will want to go ahead and start on these problems in your book.